Okay, so let's welcome our second speaker, Marcin Zabłocki, who is an MLOps architect at Getting Data, and he will talk today about MLflow. He'll actually say everything he can about MLflow in 30 minutes that he has. So please welcome, and the floor is yours.
Thanks for having me. Actually, it's 35 minutes that I was promised. So yeah, So join me today on. I will guide you through across the MLflow iceberg, and after today's presentation, you will know first of all what MLflow is, how you can use MLflow in your day-to-day operations as a MLOps engineer or data scientist or machine learning engineer. And lastly, you will know what to look out for when you are working with MLflow. I'm Marcin Zabłocki, MLOps architect at Getting Data. Career-wise, I started my journey as a data engineer. Then I've shifted to being data scientist, ML engineer, and finally MLOps engineer. I'm also a member of a technical steering committee for Kedro, which is an open source MLOps framework that I highly recommend to check out. I'm also a Lego fan, as you can see, and since 1 year already, together with my friend, I'm conducting a channel on YouTube called ML Workout. You can check it out later on. If you speak Polish, you can check out some videos there. So the MLflow iceberg that we'll be exploring today looks more or less like this. We'll start with the top, so the experiment tracking, then we'll go to the model registry, and then we'll start going deeper and deeper. So through model serving, MLflow deployment, some gotchas, plugins, and LLMs. So before we go further, raise your hand if you already used MLflow in your day-to-day operations. Cool, so not everyone. So to answer the question, what is MLflow, is not that simple. And let's see what the authors have in mind. So let's open MLflow website, and they proudly say that MLflow is an open source platform for machine learning lifecycle. And in my honest opinion, it's pretty vague. So let's scroll a little bit further and see what else is there. So they say that MLflow is a tool for tracking, and MLflow is a tool for model registry, and MLflow is a tool for storing and deploying machine learning models, and MLflow is also a tool for evaluating large language models. But MLflow is also a tool for deploying large language models, and MLflow is also a tool to package your Python and data science code. So it's like a lot of different things. So let's take a step back. Let's start from the very beginning, from the top of our iceberg, the experiment tracking part. So in every machine learning projects that you probably worked on, there will be two components. The first one will be data scientists, and the second component will be the bricks that our data scientists are assembling together, which will be our machine learning models. And those machine learning models will usually be trained, and after they are trained, they will be described by some kind of parameters and some metadata, like metrics, some name of the algorithm and the algorithm itself, and also some parameters related to model configuration. And all the trained models will have similar data. And MLflow experiment tracking piece allows you to actually store this data, store this information in a really nice structured form. So here on the slide, you can see the screen of the MLflow UI. And on the left-hand side, you can see the tab named experiments. And experiments are usually some notion of a project. So you can imagine, for example, you are doing sales forecasting. So there will be some sales forecasting project in the experiment tab. And in the center, all of the training runs that you've made, or your data scientist made, or anyone at your company did, will be stored there. And every entry in this center piece where the runs are stored will correspond to one training training run that allow you to train some model. And when we open one of those runs, here is all of the data you've seen before. So as I've mentioned, the models are usually described by some metadata. So when you open the run details, you'll see some basic things like the date when the model was run, what was the duration of the whole training jobs, but also some more important things like which dataset was used to train this model, what parameters were used in the training jobs. And by parameters here, the parameters that are stored in MLflow can be hyperparameters of a model, but also all of the remaining parameters that were used in the training job itself, and also all the metrics. You will be able to view them both in a tabular form as well as in some chart form. And last but not least, one really important piece, since every run produces some model, the model and all of the files related to model itself, like the serialized model, its requirements, some schema of data that was used to train it, will be also stored here. And first, take a closer look at this piece of a configuration here. Remember it because I will go back to it once I start talking about the MLflow serving part. But speaking of the runs themselves, so far you know that you can store MLflow runs. That you can store runs and models and metrics in MLflow. But that could be it would be great if you could find a way to compare them. And MLflow gives you exactly that. So if you have one experiment which consists of multiple runs, you can select a few of them, click compare, and you will see this nice looking table which will show you all of the differences between the models that you've trained so far. You will see how the parameters change, and you can, for example, spot what parameter changed, allow you to increase or decrease given metric, so that you can guide your project in the right direction. And obviously, besides doing tabular comparison, you can also create some nice looking charts, like this parallel coordinate chart that you can see right now. MLflow itself supports multiple visualizations, so you can generate some scatter plots and so on. And if that is not enough for you, you can immediately go to the most deepest and darkest part of the MLflow. You can connect to the database and plot some metrics on your own, but that's probably a good topic for another presentation. So let's go to the next part, which is the model registry. So far, all of the models that we've trained were just lying on a shelf without doing anything. And after some time, you will be having hundreds of or thousands of those runs stored in MLflow, and it will quickly become really unmanageable because you will not know what was deployed, for example, in staging or in production, what happened at which time, and what you are actually running in production, what was the candidate model that you trained yesterday. So the best way to organize Lego sets is catalogs, and the best way to organize models is actually the model registry in MLflow. So the model registry is another tab in MLflow, which contains a few columns. In the first column, you can see all of the register model names. Those models will have multiple versions, and those model versions can also have some aliases. And when you open one of those models, you will see another detailed view. What's important here is that besides the model name, you will see all of the historical versions that you deployed so far or that you've registered so far. And besides those versions, you will be also able to set some tags like metadata for your model versions, but also some aliases. And when we go one level deeper once again to particular version, this is something really important that you see highlighted here, is that when we go from the model to the model version and to the actual version details, you will see the source run, and this the direct connection of to the run that produced this model. So you gain full traceability back to the very beginning of your training jobs, to the parameters, to the algorithm name, to the hyperparameters, and so on. You will know, for example, that if this model in version 8 that you can see on the slide was deployed in production, you can always refer to the MLflow registry and see what was the run that produced this model. And from this UI, you can also modify all of the aliases. This is purely metadata, so you can modify anything and put anything you want that is crafted to your business needs or to your organization needs. But from the MLOps perspective, what is most interesting in this part is that you can also modify and transition those models, set the labels and tags and so on from Python code or from the REST API directly. So that means that you can, for example, plug it in as a piece of a CI/CD pipeline for model deployment. So once the model gets deployed, you can update its state in a specific version in the MLflow. So we'll know at glance by looking at the UI what you have in production and so on. And a really important side note here, I was talking metadata, and it is only metadata, unfortunately, on that part. So far, MLflow does not support any kind of a webhooks or events that you can attach to. So if you, for example, modify the alias of your model, no event will happen. So you should treat MLflow as a centralized place to know what is your current state, but in order to update the state, you need to code something on your own, at least for now. But wait, another thing. So I've been talking about models, storing the models, and more runs and different kinds of model registry and so on. But how do we actually put those models in MLflow? So that's the slide that you've seen before. You see in the artifacts the model is stored, and here is some YAML file with some metadata, and here you can spot the name flavors. And flavors is actually the name that MLflow uses to describe their integration with some machine learning frameworks. As you can see, most of the popular machine learning frameworks that you can use to train your models are supported natively by MLflow, like XGBoost, PyTorch, scikit-learn, and so on. Recently also LangChain. And if one of the libraries is listed in here, that means that MLflow has native integration with this library. And if you save the model from MLflow during your training job, it will get saved in a format that is native to this library. So for example, with scikit-learn, if you save the model via MLflow integration, it will be saved most likely as a pickle or as a joblib, while if you save, for example, from PyTorch, it will be saved in a tensor format native to PyTorch. And here you can see how it looks like from the perspective of a code. We can see MLflow run that was started, and we are logging the model at the very end. So we just call mlflow.sklearn.log model. The pattern will be the same for most of the libraries. We can also log the signature so that we'll know what schema of data was used was passed to the model before training. And that's basically it. And now consider whether it's enough for you to then take this model and serve it in production or in anywhere else. And with that in mind, with that thought, let's go to the level of the ocean right now with the model serving. So MLflow has a basic notion of serving, and you can just run simple bash command, MLflow model serve, pass the reference to the model from the model registry that I showed you before, and after a while, it will spin up HTTP server on your local machine or on a server that you can send the request to, and it will respond with the model predictions. And cool, right? Not so much, in my opinion, because why? Why? It's not cool because in the most basic form of model serving, what MLflow will do, it will go to the registry, it will take all of the files that were in the artifacts, it will download them. There will be requirements or conda environment, and so that MLflow will create a new virtual environment on the target machine or on your local machine. Then it will install all of the dependencies in this virtual environment, which can take years, and only then it will save the model. So it's not really something that you would expect to use in production, basically. So it's really not cool. And fortunately for us, MLflow authors know that it's not the best options to serve the models, so they build integration with Docker. So instead of doing MLflow serve and passing your model registry and waiting for the virtual end to happen, you can pre-build your Docker container with the model and with all of its dependencies and just serve it. So that is quite cool. It might work, but is it good enough? So far, I've been deliberately showing you the models that are mostly consist mostly of the algorithm itself. So the models look more or less like this. We have small model with random forest, which is the ML algorithm. But in a real world scenario, models look more like this. So the machine learning model itself is only like small fraction of the whole system. Usually have some custom feature engineering, custom transformation, some pre-processing, usually made not only in the code that was used to train the model, but usually as you've mentioned already here, as it was mentioned here today, there are some shared packages across your whole company that can, for example, do some standardized pre-processing in some standardized way. So it will be difficult to deploy such model. So what that means is that if you have those pre-processing stuff already in place, that will mean that all of those native integrations, because you are using custom code and your awesome package.py is not listed in officially supported list of MLflow packages, it will mean that this does not work at all. Fortunately for us, again, MLflow has answer for that. So in the MLflow package itself, there's an abstraction called Python model, which is an abstract class that you can implement, and you need to only implement two things: load contexts, so the function that will allow you to load everything from the artifact registry, and you can basically do anything here, and also the predict function, which will allow you to do any kind of a processing that you have from custom packages, any kind of a transformation on your data, and then finally return predictions. And you may think that it's good enough, but unfortunately it will break too. And does someone know why it will break? Okay, so here's the answer. And it's not related to the fact that it's a direct import here. It's just a matter of me putting it here for the slide to be more pleasant to look at. It will break even if the imports were on the top. But the important fact is that if you do MLflow custom model.log model, only this class will be sent to MLflow. And then, so if you then, for example, either build Docker container with this class or try to do this MLflow serve with virtual env installation, it will still break because those awesome packages that you've built will be not sent to MLflow. So there will be no way to MLflow to know how to install them. So there must be a way to ship our Lego sets in a better way in some nice looking boxes. And as far as 2023 and 2024, it's best way to ship any software is to have it in Docker container. So I believe that most of you already have model training code Dockerized in some way. And by putting this additional class from MLflow alongside your Docker container, you will basically get serving for free with MLflow, because during training, you will set entry point for your Docker container to be train.py or whatever. And during serving, you will actually switch the entry point to the model serve. And there are two parameters. The M is for the model, so this reference to the model registry that you saw before, and the env manager.local that will guide the MLflow tool itself to not install anything and rely on what is already installed in a Docker container. So with that in mind, everything is awesome. Okay. So far, I've been talking about the surface stuff and the stuff that you actually utilize when you are using MLflow as a user, I would say. But most of us here are probably related to MLOps since you are here. And since MLflow is an application that you need to deploy somehow, here are the deployment options and some things that you need to look out for when you are deploying the models. I like to say that there are 3.5 options to deploy MLflow in your environment. The first two are not that useful, but are mostly related to the local deployment. So if you are starting your journey with MLflow, you can start with that. The most basic thing is to have everything stored in local files. So that means both artifacts and metadata, which is all of those runs, those metrics, and so on, will be stored as flat files. Not that useful for collaboration. The second option is to separate the artifacts from the metadata. So now artifacts will still be stored on a disk, but the metadata will be stored in a database. Locally, it will be usually SQLite. Still not so useful for collaboration. And the third option is the actual remote tracking option, the most useful one. And the first one that you can see in the bottom that allows some collaboration, that allows you to share your runs, share your models, and so on. So in that configuration, there are three components. The first one is the central piece, which is the tracking server. The MLflow as an application will be deployed on some server. The artifacts will be stored in the cloud storage of your choice if you're running on a cloud, for example. And there should be also some centralized database that you can connect to. And going into this third option and trying to deploy it, it's not always that pleasant, because first of all, if there's a database that you need to have, you also need to maintain it, and no one from MLOps world wants to maintain databases, so probably should use one of the existing solutions like Cloud SQL or RDS for AWS or something else from your cloud provider. For the tracking server, you don't want to maintain tracking server. You don't want to maintain any server at all. So you're probably good with some container-based solution and with some serverless solution. So MLflow itself provides officially supported Docker image. So you can just deploy this image to either Cloud Run or Azure Container Apps or AWS Fargate, for example. And with that, you get free HTTPS, free authorization, and you get serverless environment. But unfortunately, you are in the serverless environment, and there will be some cold starts and something else. And question for you, do you know what it is when it comes to this architecture that may go wrong? A little hint for you, it's related to this part. Okay. So the problem here is that see that although we have artifact storage as a cloud storage, GCS, S3 or whatever, which is potentially infinitely scalable, everything that goes to this cloud storage when goes through the tracking server. So that means if you're running training job here and you are storing large language model that has like a few gigabytes of size, all of this traffic will first go to our tracking server, and then tracking server will send it to cloud storage. And you will quickly exhaust, for example, payload size for Cloudrun or Fargate. So that's why I've mentioned there are 3.5 options. And the better option to deploy MLflow tracking is with the last architecture. So here, the cloud storage is separate. And as you can see here, your training code actually accesses cloud storage directly. But it's important to know that if you are deploying it in that way, whenever your code says to MLflow, hey, please store this artifact, it first goes to the tracking server, then tracking server responds to our training job with, hey, please store your artifacts here in, for example, S3 in this particular folder. And then your tracking code will know how to store it directly using S3 native APIs or APIs and protocols native to specific cloud provider. And at the same time, since the MLflow tracking server is responsible for giving those paths, the MLflow UI will be able to visualize those data and all of the artifacts that you store for you. Next thing related to authentication is that you need to know that MLflow is not that enterprise ready. So if your organization is using a single sign-on, you will have to build something on your own, at least for now. So usually in our deployments, what we do is we use OAuth proxy. So we connect MLflow with OAuth proxy, and on the other side with our SSO provider like Google. And thanks to that, you will be able to authorize to the MLflow via your organization login procedure. You can check out the whole description on our blog. I will probably send this presentation later on, so you'll be able to access it. But what's also important in terms of actual authentication is that, at least for now, MLflow does not have the notion of user or namespaces. So even if you sign in as some identity and you will be logged in as you in your organization, MLflow does not have a concept of a user. So right now, MLflow is like a shared instance across your whole organization. So if you, for example, want to have some isolated branches or isolated teams that need to have separate pieces of MLflow accessible, it's probably better to deploy multiple instances of MLflow, at least for now. But MLflow is still evolving, and a few months ago, they actually added some notion of authorization. So they've added concept of permissions, so you can create multiple shared still users that could have some different roles like reading, editing, and managing. So they are going in the right direction, but they are not just there yet, and still under some basic authentication. However, because MLflow itself is written in the backend server of MLflow is written in Flask, they're actually exposing some calls, some entry points that you can extend, and for example plug in your custom logic for authorization if you are not using SSO. And speaking of extendability of MLflow, let's go one more layer deeper into plugins. So since MLflow itself is a Python, mostly Python-based thing, they're actually exposing many different entry points that you can extend. So if you write your own Python package, you can specify some entry point from and you can look up the MLflow documentation to find one of those. So you can, for example, implement your own tracking store, and instead of storing data, for example, in SQL database, you can implement your own store, for example, to store data in MongoDB and some other places. You can also, for example, implement the plugin for deployment. So you can, for example, use native integration to serve the models and provide your implementation of deployment procedure. That's how, for example, SageMaker plugin is implemented. They've extended this deployments entry point, and thanks to that, you can just take model from MLflow registry and push it directly to SageMaker. And on the next slide, I will show you the highlighted one, request header provider. It's a simple extension that is related to our SSO that you saw on the previous slide. So in here, you can extend the capabilities of MLflow on the client side. So imagine if you have deployed MLflow instance under SSO, you need to have all of the requests authorized. So you can write this plugin to obtain token from your SSO provider and attach authorization token to every request, and MLflow will call this endpoint, this extension point automatically every time you make a call in the MLflow itself. And you can check out the code for this whole plugin, for example, here for GCP on our GitHub repository. And also there are a few community-driven plugins that you can check out on the official MLflow website. Okay, last but not least, there should be no presentation in 2024 that does not mention LLMs. So they're actually on the same, they're actually trying to catch the train also in MLflow. All of the stuff that you'll see from now on is totally experimental. It might break, it can break even tomorrow. So far, they are focusing on two parts related to LLMs. The first one is evaluation, and the second one is deployment, and you will see why it's deployment in a few slides. So for the evaluation, there are a few things. The first one is the most basic one, standard evaluation metrics for text tasks like question answering and text summarization. You can plug in the model and you will be able to calculate those metrics based on the model, based on the LLM responses. But one interesting thing is that they actually created something called Gen AI metric, and it's a tool that allows you to use LLM to evaluate LLM. So you can use black box to evaluate your black box. And you can create a prompt that will actually provide some information how you want to judge your LLM responses, and you can even calculate some mean and metrics and variance and so on based on the responses from another model. To be honest, I'm not sure if that's useful. Apparently, it's something people want, so they actually made it. But what is useful is the prompt engineering UI. So they recently added this, and the prompt engineering UI allows actually to create multiple prompts for your given task and attach multiple models that you have deployed and run the evaluation. And after you run this evaluation, you will be able to explore it in a table. So as you can see in here, we have two different prompts for the same model and for the same like an input when the article, so the context and the question is passed to LLM with two different prompts. You will get totally different results, and MLflow allows you to summarize that, to run all of the prompts against multiple models. So it will be probably extended in the future, but it's useful if you are working with base apps. And now the last part related to deployment. And when you think about LLM deployment, it's mostly about tools like OpenLLM or VLLM or TGI, where you focus about GPU acceleration, quantization, some dynamic batching, and so on. And unfortunately, MLflow does not compete with that. And what they mean by deployment is absurd in my opinion. Previously, they called it LLM Gateway, and it was a better name. So they rebranded, but they name it deployment now. But what they mean by that is that instead of focusing on deployment, they focus on the MLflow to be like a proxy to all of the major cloud providers for LLMs. So if you are building LLM application, instead of going directly, for example, to Open API, you can build your application against MLflow APIs, which will probably not change that much. But if the cloud provider APIs change, MLflow will cover that for you. You will be able to switch models. I think it will be really cool to see it working in the production. So now take a breath, relax, take out your phone because there will be some QR codes that you can scan. And before it's almost end of the presentation, so I would like you to remember 3 things about MLflow today. So first and foremost, the MLflow itself is great for experiment tracking and all of the things related to storing metadata of the training jobs, comparing them, plotting charts, and so on. It's a great building block for MLOps platforms because it can be a centralized place for not only the experiments but also for a model registry, and you will be able to centralize all of the deployments of models around the MLflow and know the actual state. And for some cases, it can be like good for end-to-end workflows. It will be probably not the most performant one, but it's a good starter. You can actually have end-to-end working solution from training to the actual serving using MLflow. And yeah, that's it for today. I will really appreciate if you can, if you, for example, subscribe to our YouTube channel. It will be highly appreciated. If you speak Polish, you learn about some stuff related to machine learning, not only about MLOps. And if you are interested in free MLOps consultation, you can scan the second code, which will lead to a form that you can fill in and will contact you. And I'm Marcin Zabłocki, and it was MLflow Iceberg for you. Thank you very much.
Okay, do we have any questions? Don't be shy. Mhm.
Thank you for presentation. I wanted to ask, did you make comparison MLflow to other competitors, and why you prefer to choose MLflow?
Yes, so I've compared against a few. It's not a matter of me choosing always MLflow. It's usually based on what the client requirements are. For example, with personally, I really like weights and biases because of the UI and so on. There are, like you probably know, there are many other. Comet ML, for example, was already mentioned today. And the most important factor related to MLflow is usually the fact that it's free. So even in enterprise, you can deploy MLflow for free. Obviously, you need to manage that, but yeah, sometimes companies don't want to pay to something even if it's better. Another thing that I've never noticed on my own, but I saw from different comparisons, is that those tools really differ on the part related to the performance of the UI. So MLflow in the version 1.x was really suffering from UI performance, but they fixed it in 2.0, so it's probably on par with different experiment tracking solutions. And also, yeah, when it comes to the governance, it's always easier to have MLflow deployed in-house because then you can be under a private VPC you will not get exposed, while with cloud-based solutions like weights and biases, Comet ML, usually unless you pay really a high price for enterprise level, you are using software as a service, which can lead to, you know, data leakage and so on.
Thank you.
Any questions? Maybe in the meantime, I will have a question. You talked about serverless deployment of MLflow, and obviously if you use some blob storage, it will be serverless, Cloud Run, it will be serverless, but you still need to have a managed SQL database. Is there any way to avoid this, to use any serverless database also for storing metadata?
A great question. So MLflow by implementation uses SQL Alchemy. So any dialect and any server of SQL that is supported by SQL Alchemy can be attached there. So yeah, for example, in AWS, there is actually a serverless database that that you pay for usage. And if you are really into like serverless databases, you can use the plugin extension point that I've showed for tracking, and you can implement your own store. However, there is actually issue on GitHub raised about support for MongoDB, because it's one of the most popular document databases. And because they are so tightly integrated with SQL Alchemy and all of the other things, the full implementation of the whole tracking store for MLflow is really difficult. So yeah, you need probably to stick to SQL for now.
Thank you.
Actually, I have one question. You said about MLflow serve, and as I understand, it serves models locally. But is it possible to use some native cloud solution like Vertex serving or something like that?
Yeah, so the MLflow serve that I've shown is used as a like built-in HTTP server for your models. And with the MLflow deployment entry point for in the plugins section, you can actually write a plugin that will deploy the model from MLflow into some cloud native solution. Officially, the one that is supported probably by them or by AWS, I don't remember correctly, but the deployment against the SageMaker is natively supported. So you can just type MLflow deploy SageMaker, then URI of your model, and it will actually spin up everything on the SageMaker side, and it will deploy it there. And you can write, for example, something to target Vertex. There is no official plugin for that.
Okay, thank you.
Any more questions? Okay, if not that, thank you very much.
Thank you very much.